And now for our first speaker of the afternoon. James Shore leads organizations in scaling software development, most recently for Open Sesame, where he is Vice President of Engineering. He is the author of the Agile How-To Guide, The Art of Agile Development, co-creator of the Agile Fluency Model, and a recipient of the Agile Alliance's Gordon Pask Award for contributions to Agile practice. The title of his talk, Testing Without Mocks. Please put your hands together for Mr. James Shore.
Good afternoon, everybody. This has been a fantastic conference, hasn't it? I'm just loving it. And the rain has been a surprise, too, because in Portland it doesn't rain like this. It just rains all the time, but only a little bit. So, quick question for you. How many of you have a test suite? How many of you are willing to raise your hands? About the same number of people. Okay. So, I asked how many people have a test suite. How many of you like your test suite? Like 10 people raised their hands, a much, much smaller proportion. All right, let's dig into this a little bit more. How many of you have a test suite that's too slow? Too slow. About a quarter of the folks. How many of you have a test suite that fails randomly? It's flaky in some way. About, again, maybe 10%, I'd say. How many of you have a test suite that's brittle? It fails when it should pass? Nobody. A couple people. How many of you have a test suite that's unreliable? It passes when it should fail? A couple of people. How many of you are tired of raising your hands? About the same number. All right. How many of you have a test suite that makes it hard for you to refactor your code? More people are answering yes to that question. And how many of you have a test suite where the tests are hard? This is the last question, I promise. How many of you have a test suite where the tests are hard to read? A lot more. I'd say, again, about 15%. All right. Well, I'm James Shore, and I've been writing tests with test-driven development for the last 24 years. I've been struggling with these problems from the beginning. And I've come up with a bunch of different solutions, and they were all horrible, and I was embarrassed to share them. But in 2016, I tried another approach, and it worked. I mean, don't get me wrong, it's still horrible, but at least at first glance. But when you get past one key compromise, which I will get into, the benefits are dramatic. The tests are fast, reliable, easy to read. If you use this technique, your code will be easier to refactor. And you'll be able to simplify your code by getting rid of your mocking framework, getting rid of your dependency injection framework if you want to, getting rid of all the extra interfaces in your code if you have a statically typed language, and most of your end-to-end tests. You can survive on just a couple of end-to-end tests with this technique. So, let's dig in. So to summarize, many people have test suites that are slow. We had a lot of people raise their hands for that. Flaky, a lot of people raise their hands for that. Brittle, unreliable, hard to read. And the fundamental challenge with these test suites is dealing with external systems. There's a reason that testing tutorials all talk about logic. They have things like the bowling game and other stuff that's pure logic, and that's because pure logic is easy. It's a great way to learn test-driven development or testing in general, but it's super easy. But pure logic isn't what we deal with in our regular day-to-day lives most of the time. We've got front ends rendering to the user and responding to events. We've got back ends gluing together databases and microservices. It's all I/O. And a testing approach that ignores I/O, as most testing approaches do, isn't going to work for us. So let's take an example. We've got a little web server. This is an example I'm going to use throughout this talk. There will be live coding, by the way, so if you're in the back, there's lots of seats up here, and you'll have a better view when we get to the live coding part. we've got a little web server. It's going to encode text using route 13. The home page receives this post request from the browser. They parse it, calls a route 13 microservice to encode the text, and then renders the result. So the web server is responsible for parsing and rendering. The route 13 service is responsible for route 13 encoding. Clear? Got it? Okay. So what will happen is when the user types in some data onto the web page, and they click submit or translate, the browser will send a post request to the server. The home page controller will receive that request and parse it. It will make a GET request to the service, which will respond with the encoded text, and then the controller will take that encoded text and render it as HTML, send it back to the browser to render to the user. So let's take a closer look at how that web server is defined or designed. The home page controller class is responsible for parsing the browser request and rendering the response. The route 13 class is responsible for providing an abstraction of the route 13 service. And then the HTTP client class is a low-level HTTP request wrapper. So the question is, if we wanted to test that controller, the home page controller, how would we do it? One way we could test this is by imitating the browser, testing end-to-end, seeing the code actually work all the way through to the route 13 service and back. And these sorts of broad tests are tempting, but they are slow, they're hard to maintain, and they tend to be flaky in a real large system. Another option is to write a narrow test that focuses on just the home page controller. The problem is that pesky call to the route 13 service, I/O. It's slow and it's a pain to set up. So most people will inject a mock or a spy in place of the route 13 client class. And that way our test can focus on just the home page controller. And this seems like a great option, and it does work. But it has trouble with change. You end up with unreliable, brittle tests. Let me explain. So imagine you make a well-intentioned change to the route 13 class. You even update its tests. Works exactly the way you expected it to. But without realizing it, the change you made had an unexpected side effect on home page controller. It no longer works the way home page controller assumed it would. And because your home page controller test doesn't run the real route 13 client, it doesn't detect that change, and your test passes even though your code is broken. So it's an unreliable test. Mock-based tests are also brittle. Imagine you make a design change to route 13 client. Doesn't change any behavior. All your code still works. But even though everything works, your home page controller test will fail until you make the same change to the mock route 13 client. That brittleness makes refactoring more painful, especially in languages without good automated refactoring tools. And then finally, although this is more subjective, I find that mock-based tests tend to be hard to write and to read. And that's because the tests talk about the interactions of the code rather than the methods it calls, rather than the behavior. Now, some people would argue that the interactions are behavior, but I'm talking about externally visible behavior to the class. Also, the automaticing frameworks that most people use have this ugly, complicated syntax. So that's the problem. Broad tests are slow and flaky. Mock-based tests are unreliable, brittle, and hard to read. But what other options do we have? So let's go back to the beginning. We want to write a narrow test that focuses on just the home page controller. The problem is that pesky call to the route 13 service. It's slow and a pain to set up. How can we test this without using a mock? Ultimately, we want to disable the route 13 service. Because as soon as that route 13 service is in the mix, it's slow and it may not work properly all the time. And we want to disable it in the context of homepage controller. Encapsulation is a key design concept. Homepage controller knows about Route 13 client, but it doesn't know about HTTP client or the details of the Route 13 service, and we don't want it to know that. We want that to be Route 13 client's responsibility, not homepage controllers. That way that when we think about homepage controller, our scope of understanding is nice and small and easy to understand. So what if we make this problem of disabling the Route 13 service, what if we make this problem Route 13 client's responsibility? Encapsulation. And this is the fundamental breakthrough or perhaps heresy behind my approach to testing without mocks. It's called Nullables. A nullable is a production class that has an encapsulated off switch. That switch allows you to disable access to external systems. Specifically, in this example, Route 13 client would be nullable and would have a setting that turns off the Route 13 service. The details would be encapsulated, so homepage controller wouldn't have to worry about them. Some people really, really hate this. Remember how I said I came up with a bunch of horrible ideas and this one's horrible too? That's the reason, right there. But it turns out when you do this, it enables a lot of simplification throughout your entire system. Also, sidebar, they're called nullables. Who here hates that name? Some of you are being generous, I think. Everybody hates the name. I even have come to hate the name too. It was inspired by the null object pattern and things like the null log class that you see in .NET. And it's too late to change it. I've been talking about this for 6 years now, and I'm worried that if I change it, it will confuse everybody. So nullables it is, even though there's a million other things called nullables or nulled or something. So let's talk about how this works. We're going to add a create null factory method to Route 13 client. Its job is to create a nulled version of the Route 13 client that doesn't talk to the Route 13 service, just like null log doesn't actually log. Then in our tests, we'll set up the homepage controller to use the nulled version of Route 13 client. The trick here is that the nulled Route 13 client uses the exact same code as the normal version of the Route 13 client. The only difference is that when it's created, it creates a nulled version of HTTP client. The nulled HTTP client is also the exact same code as the normal HTTP client, except that it stubs out the third-party code that talks to the Route 13 service. I need to repeat that. The secret to nullables is that the same code runs in your tests as in production. It's not a special version of the code. It's not a subclass. It's not a mock. It is the exact same code. It's not a flag with an if statement. It's the exact same code. There's a trick to stub out third-party code, but all of your code is identical. And this solves the problems we have with mocks. The test is fast, just like a mock-based test. Actually, it's several orders of magnitude faster than using a mocking framework. It's deterministic, just like a mock-based test, so it won't fail randomly. But unlike a mock-based test, it's reliable. If you change Route 13 client in a way that breaks homepage controller, its tests break. And that's because your tests are using the real Route 13 client. It behaves just like the real Route 13 client because it is the real Route 13 client. Let me repeat that one more time. You change Route 13 client, or you change Route 13 client in a way that accidentally breaks homepage controller, and your homepage controller tests will break. And that is a game changer. The tests are robust against design changes too. If you make a design change to Route 13 client, you don't have to change the homepage controller tests because the tests are using the real Route 13 client. Doesn't need to be changed to match the real Route 13 client's behavior because it is the real Route 13 client, and it has the exact same behavior as you see in production. So let me summarize the differences here. Broad tests are easy to write and read, but they're slow and flaky. Mock-based tests are fast and deterministic, but they're unreliable, they're brittle when you refactor, and they can be hard to read. Nullables provide the best of both worlds. They're fast, reliable, support refactoring, and they look like normal tests, like the kind you see when you do the bowling game and so forth. And I'll show you an example in a moment. But nothing is perfect. All engineering is trade-offs. And the big trade-off with Nullables is that you have to add a create null factory method to classes that talk to external systems. A little bit of good, a little bit of bad. This is a tool in your toolkit. I'm not going to tell you which one of these techniques to use, but they are all compatible. You can use mocks and nullables in the same test. Personally, I think the trade-off is worth it. The tests are fast and reliable. You don't need a mocking framework, unless you're still using mocks in your code somewhere. You don't need a dependency injection framework, unless you're doing some complicated stuff with stubs elsewhere in your code, but you don't have to. And you don't have to add interfaces all over your code base. You don't need integration tests to make sure everything really works, in addition to the unit tests that you've got. I do keep a few smoke tests, and by a few, I mean like 3 or 4, just to make sure I haven't made any mistakes. But if those ever fail, it means that I messed something up in my code, in my tests. My test suite completely covers everything that the end-to-end tests do. I just have them there as a safety net. When they fail, it tells me to fix my tests, not that they're required. So, enough talk. Let's see this in action. I'm going to do a demo live to show you how this works. And a reminder to go to Slido. If you have questions about this, put them into Slido and I'll answer them in about 20 minutes. So what we're going to do in this demo is we're going to build the homepage controller from scratch. Now, as a reminder, the homepage controller serves the homepage. It receives a post request from the browser, uses the Route 13 client to call a Route 13 service, and render the response. We're going to use test-driven development to write the tests. We're going to create a nulled Route 13 client to ensure that our tests are fast and deterministic. And our tests don't need to know how Route 13 client works. That's encapsulation. But under the covers, Route 13 client is going to create a nulled HTTP client, which is going to turn off communication with the Route 13 service. All right, now for the dangerous part. Okay, so what I've got here, I need to pull up the right branch. All right. Okay, so what we have here is a predefined test file just to make our lives a little bit easier and faster, but all the tests are empty. And over here is a predefined homepage controller, again, just to make our lives a little bit easier. It's got a constructor that takes the Route 13 client and clock dependencies. We're not going to do anything with clock today, but that's for handling timeouts. We've got a get async method, which handles get requests. We've got a post async method that handles post requests. Each of those take a request object, which represents the request coming from the browser, and a config object, which is how we do configuration. If you look down in the lower left, you'll be able to see, let me bring that up a little bit better. You're going to be able to see the keystrokes I'm typing, and when you see me press that keystroke or that keystroke, I'm switching between editors. Here's the tests, here's the production code, tests, production code, tests. Okay, once again, use the Slido link if you have questions, and let's go ahead and get started. So the first thing we're going to want to do is we're going to render the home page. If I run this thing right now, this is what it would normally look like, but because I checked out the branch with no code, I try to do that, and I get an internal server error. We look at the logs, and what we see is an emergency. The request handler returned an invalid response. Specifically, it's returning undefined because I haven't programmed it. So first thing I want to do is implement support for GET, for the GET request coming from the browser. So I'm going to need a controller, which is going to be our new homepage controller, and that's going to take a Route 13 client and a clock. And then on that controller, I'm going to need to call getAsync, and that's going to take a request and a config. Oops. And I'm going to need to get the response back from that, and then I'll assert on that response. Now, before I can construct the homepage controller, I need a Route 13 client. So I'm going to make a Route 13 client. Now remember, Route 13 client is our big dependency. The Route 13 client is what calls the Route 13 service. And because of its encapsulation, we don't need to know how it does that. We just know that it does. So we're going to need one of these things. And the way we do it, because we're in our tests, we could create it in normal production mode, where it does talk to the Route 13 service, or we could create it in a nulled mode, where it doesn't talk to the Route 13 service. This is production code. It is tested like production code, and there actually are production uses for nulled objects, which, for example, I use it for cache warming on my real code. But admittedly, mostly it gets used in the tests. So I'm going to go ahead and create null on the Route 13 client. I'm going to create a clock. Clock is external state, so that needs to be nulled out as well. We're going to need a request, which comes from the HTTP server. And we're going to need a config object. Config is just a data container. It's not I/O. But because, once you commit a little bit of heresy, you might as well commit all the heresy. Most people would construct this config object by having what's called an object mother, something in your test code that will construct things for you with defaults. But I'm like, well, I like cohesion. I like my code that's related to be close together. I'm going to put that object mother right there in the www-config class itself. I'm going to call it create test instance, so I know that that's only for use in tests. If you hate this, this is okay. You don't have to do this. This is not part of the Nullables pattern. But I'm like, once I got over this hump, I'm writing all kinds of crazy stuff. Okay, I believe that might even work. Let's find out. It looks like it did. Here, let me make that more visible. And can you all turn up the computer audio just a bit more? A little bit more. There we go. You hear that bell? Every time I test pass, it makes that dinging sound, and I start salivating like Pavlov's dog. It makes me happy. You don't have to do that either, but it makes me happy. All right, so our tests are passing. Now we need to do an assertion. We're going to assert that the response is equal to our homepage view's default homepage. And that should fail because we're not returning anything. Yep, that failed. We expected a promise. Oh, that's not right. I get this wrong every time. See this little word here that says async? That means I'm supposed to put an await in front of it. All right, now it's failing for the right reason. It's expecting undefined to equal our homepage view. And we're getting undefined because homepage controller doesn't do anything. This is JavaScript. You can ignore this ensure signature stuff. That's my runtime type checker. So I'm going to return the homepage view's homepage. Now my tests pass. That's it. And if we actually run this code, there's our homepage. Look at it in all of its glory. Professional designer right here. User experience. What is that? Okay, we don't have this working all the way. If we type in, for example, some secret and we want to translate it, it's going to fail again because we haven't implemented the post method yet. But we're making good progress. So let me just show you this again. We're doing a bunch of creating of dependencies, and it's fairly straightforward. We just call create null or create test instance in one case. Then we pass it through, and we do a normal assertion. So we're going to do the same thing for our post as well. We're going to need a controller. I'm going to just copy and paste. Yeah, copy and paste. That's actually really is bad. I'm not that much of a heretic. So we'll get to the point where we're fixing that. And we're going to call controller.postAsync. And we're going to need to give it a request and a config. And we're going to need to remember to await it. And then the question is, what are we going to assert on here? What I want to do here is make sure that when we do a post, that we are telling the Route13 service to transform some text. And usually with an interaction-based test, a mock-based test or a spy-based test, what you would be doing is saying, did we call this specific method on Route13 client? But this isn't an interaction-based test. We are treating Route13 client as a black box. We know it has a method, but which method we call doesn't matter to our tests. We just want the correct behavior. So we need a way of knowing how was the Route13 service called. Well, first, let's go ahead and get instantiation of our Route13 client. And then we're going to do something called output tracking. We're going to say that our Route13 requests are equal to the Route13 client's tracked requests. And now, anytime we make a request of the Route13 service, that will be recorded in this array. Not the method calls, the requests, a representation of the request that we're making. And that's a key difference, because when the method name changes, our tests don't break because we don't need to change this data. Let's see, we're going to need some other stuff. We're going to need a clock, so let's grab that. We're going to need a request, so let's grab that. And we're going to need a config, so let's grab that. And I believe this will pass. All right, now we need to assert on this. We're going to assert that our Route13 requests contains some representation of the request we're making of the Route13 service. What is that representation? I honestly cannot remember. So I'm just going to say there's something that comes back. And I'm going to run the test, and I expect that this will fail because we're not making any requests of the Route13 service. And that's what's happening. It says we expected something to come back, and what we got was an empty array. OK, now we can go into our production code. And here's our post async. We're going to say this Route13 client, which is just saved off for us in the constructor, we're going to call transform async. That is the method that actually does the transformation, makes the calls to the Route13 service, does the Route13 transformation. It wants a port. I'm going to say 42. It wants the text. I'm going to say some text. It wants a correlation ID. I'm going to put 000. And that's the call we're making. And I need to remember to await it. And now when we look at our test data, we're seeing that we got an object representing what we've asked the service to do. Here's the port, the text, the correlation ID. So I'm going to put that into my code, my test code. We've got a port of 42. Yep. We got a text of some text. Yep. And we got a correlation ID of something. Oops. By the way, this is how fast my tests run in real life. They take about 50 milliseconds on average. That's partly because I'm doing some fancy dependency analysis and only running the tests that have changed, but it's also because they run at about a rate of several thousand per second. OK, so that's working. Now, this is obviously not good enough. We've got a whole bunch of hard-coded data. What we need to do is to provide a real port, provide a real correlation ID, provide some real text. Let's start out with a port and the correlation ID. That is being provided through the config object. And I'm going to take my test instance here, and I'm going to put in the Route13 service port, let's say 999, and the correlation ID, which let's say my correlation ID. And I'll update my test to match. And this should fail because our test isn't using that data. And that's exactly what's happened. So now here in my production code, I will change the config to be the Route13 service port and the correlation ID to be the correlation ID, and now it should pass. By the way, does this seem like stupidly small steps. This is not for the purposes of demo. This is how small of a step I actually take when I'm doing real programming. And that's because I've learned through very hard-won experience that I'm faster when I take smaller steps. That's not about nullables either. That's just generally good testing practice if you're doing TDD. Okay, next up, we want the text here to come from somewhere. That needs to come from the request. What we're doing, remember, what we're doing here is we are going to press translate. This is going to make a post request to the homepage controller, and that homepage controller needs to pull that text out and pass it through to the Route 13 service so it can do the transformation on it. So how do we tell it that that's what we want to do? And this is another aspect of the Nullables patterns. One of them is configurable, or one of them is the output tracking, which you're seeing here. The other one is what's called configurable responses. This right here, this is our request. And we can tell it that we want the body of that request to be whatever the form data is. It's going to be the actual form data. I'm going to use hello world like that. So that's what we're actually sending, as the text form field with hello data with URL encoded, hello world that's URL encoded. And we're going to expect that we decode that in our controller and pass hello world to our Route 13 service. That's failing because we're not doing that. So now I go into our homepage controller. We got a request here. We're going to read the body, read the body as a URL encoded form. That's async, so I have to await it, and that's going to be our input. Actually, no, that's our form data. And then our input is going to be the form data with the text field and the first one of those. And there's a lot of edge cases I'm not dealing with right now, but I would normally write them on my note card and say, don't forget to deal with what do we have? What if we have no text fields? What if we have multiple text fields? What if we have other text fields? But I'm not going to do that today because we've only got 13 minutes left. There's our input. I have to remember to pass it through. And with luck, this will work. And it does. So that's nice. So that's our next test. Post ask the Route 13 service to transform some text, and it does. All right, next, the Route 13 service is going to transform that. It's going to send some data back to us, and we want to render that into our page. So let's do that. We're going to need a controller. Man, this cut and paste stuff is getting a little bit old. We're going to need to make a call to the post endpoint. We're going to need to get the response from that. We're going to need to assert on it, which I'll do after I've got the rest of this set up. We're going to need a Route 13 client. We're going to need a clock. We're going to need a request. And we have to do a real request because we're parsing the data, and if we don't do a real request, then it will blow up on us. But because I don't care about the details of the request, I'm going to call this actually irrelevant input. And I set that constant up in advance because that makes it more obvious for me when I'm reading this. Okay, let's see, we got a request. Oh, and we're going to need a config object. And this time, we don't care about the port or correlation ID because we're not testing those things. So I'm just going to take an unconfigured test instance. It configures it with some defaults. And I believe that will work. Yes. So we've successfully set things up, but we haven't done any assertions yet. And then we're going to assert that the response is equal to our homepage view, but this time with, oh, well, we're forgetting something, aren't we? I need to set this up so that the Route 13 service gives us some data back, but we're not talking to the Route 13 service, so how do I do that? Well, this is the configurable responses again. Specifically here, when I set up the Route 13 client, I'm going to tell it that the response that we get back from the Route 13 service should be, let me check my notes here, my response. Now this looks somewhat like configuring a mock, but it's not. Normally what you would do most of your services are going to be more declarative. They have a certain state, and what your configuration is going to do is say, this is the state they are in. It just so happens that the route 13 service is more imperative. You call it with a particular thing and get a certain thing back. So I'm telling it what to give back. And now, let's make sure this still works. Yep. Now I'm going to say that we get a home page view of my response. And that's failing because homepage view is not a function. Well, that's not right. Let's try homepage view.homepage. That's more like it. We're getting undefined back. So what I need to do is, here in my production code, I'm going to get the output from the row 13 client, and then I am going to return the home page with the output inside it. And there it works. And now, if I translate this secret message, fingers crossed, the gods of live coding demos, please be kind to me. Spoilers, the butler did it. That is how nullables work. But I feel like these tests are still kind of ugly. There's all this duplication in there. So I'm going to clean this up a little bit. Now, the thing about nullables is it's just normal code. You're just calling methods. You're not doing anything fancy. There's no magic. I'm not even using a fluent expectation assertion approach. I'm just calling methods because that's why my simple brain likes my code. I like my code simple. So because it's simple, I can just take stuff like this. I can factor it out into a method called getAsync, and there we go. That's our first test. And isn't that pretty? We're going to get async, and then we're going to assert that we rendered the home page. Let's do the same thing for our post. To do this one, I'm going to pull out the data that I pass in. So let me pull out the body and the service port and the correlation ID. And let me clean this up. Shorthand, shorthand. Let's pull this up here. Pull this up here. Shorthand. There we go. Let's bring these together. Bring this together. All right. That's still working. Now I can take this code, which looks the way I want it to, and I can factor it out into a method called postAsync. Except that I want this to be an object because in JavaScript that allows me to do named optional parameters, which is nice for future work where I make changes to it. So I'm going to make this an object as well. And I'm going to do the same thing for the return values. If I want to have more return values in the future, it will save me having to go through and edit all my existing tests if I make this named optional parameters. So let's do that here. There we go. And I just realized I didn't do that on my getAsync, so I'm going to do that here and here. Okay, that's good. And now that I've done that, I can pull these back out and inline my variables. I think that's a nice test. We're going to post this body, text equals hello world, this port, this correlation ID, and we're going to expect that the route 13 service is called on port 999 with the text hello world and the correlation ID of my correlation ID. This simple example, it looks sort of like what you see from a mock, but it's really not. There's some design subtleties that I don't have time to get into with this, but we're talking about the behavior of the system, the state of the system, not the methods that are being called. Although because this is a simple problem and it's reasonably well designed, the behavior and the method calls are very similar. But in the future, and in the real future this did happen, when I refactored the code and the way the transform worked to be to work with timeouts and failures and other things, I changed all the method calls and everything the way things worked under the covers. And these tests didn't break because they don't talk about the method calls. Okay, let's go ahead and do this one as well. This, we've got to specify the route 13 client's response, and we don't have that in our post async yet. So I'm going to go ahead and add that. That's going to be the route 13 client response. That should still work. And the this next post request test doesn't specify the body or the route 13 service or the correlation ID. It doesn't care about those things. So I'm going to default them to some default values. So the body I'm going to set equal to text equals irrelevant input. The route 13 service port I'm going to default to irrelevant port. The correlation ID I'm going to default to irrelevant correlation ID. And the route 13 client response I don't have a constant for, and I have no idea why I didn't put a constant in there, but I don't. So I'm just going to say irrelevant route 13 service response. And then we're also going to need the response back from the controller, which we're not doing yet. So let's go ahead and get that here. And we will pass it back here. And that's why we use an object rather than just passing simple values. Okay. And now if I've done that right, fingers crossed, this code is no longer necessary. I should be able to just say await post async with what am I going to need here? The response of my response. And I'll have to lint it properly. What did I do wrong? Response is not defined. Oh. Okay, that should have worked. What did I do wrong? See, this is the route 13 client response. Oh, I think I called it route 13. Oh, I never passed it through here, did I? Response, route 13 client response. The demo gods are not being kind to me this time. What did I do wrong? I believe that needs to be an array. There we go. And in fact, there's my runtime type chipper telling me that. It should have been an array, but it was an object. There is my code. Let me go ahead and wrap this up, because we are almost out of time. I just like to take my helper functions and put them at the bottom. And we are done here. So that is what testing with Nullables looks like. And let me go ahead and check out the full version of this code. It's also available in TypeScript, and, but I'm not going to show you that because it makes everything more complicated. So this is how the code works. I think it's very readable because it's just do stuff, assert stuff. Do stuff, assert stuff. So get renders the home page. We're going to get async, and then we're going to see that we get the home page back. Asking, when we do a post, we transform the text. Well, here's our post with our body, port, correlation ID, and then we're asserting that that request was actually made. We render the results of the route 13 service call. Post async with this response coming back. Yep, that's the page we've rendered. What about the edge cases? Well, when there's no form field found, we're going to do a post with no body. And we're going to get logging out. How many of you skip your logging because testing your logging because it's too much of a pain in the butt? Well, it's easy with this approach. We're also going to check that we rendered our normal home page, and we didn't call the route 13 service. We should get a warning when where the duplicate form field. Same thing. We post, body, logging, rendering, no request to the service. What about edge cases? What if the service returns an error? Well, encapsulation. Our route 13 client is programmed so that if we pass in the route 13 error parameter, it will fail. And so what happens? We render the page with a route 13 service failed. We log an emergency. What if the route 13 client doesn't respond at all? It answers the phone and then just hangs out. And you're like, hello, hello? that kind of stuff happens, you need to test it. Well, Road 13 client encapsulations is programmed to work exactly the way we want it to, so there's a Road 13 hang option. When we say true, it doesn't respond. Then we'll just wait for the request timeout, and what we'll see is Road 13 service timed out. We'll see that the request was canceled. So there we've got the call being made to the Road 13 service, and then the request being canceled on the Road 13 service. And we'll see another emergency being logged for us to deal with. I think that these tests are really nice and clean, and this is what it looks like in all my code using Nullables. So I've got 22 seconds left. Let me go ahead and go back to the wrap-up here. So, in conclusion, Nullables simplify your code. Fast, reliable tests. You don't need a mocking framework. You don't need dependency injection frameworks. You don't need interfaces on all your code in languages other than JavaScript. You don't need broad tests because they are testing the real code all the way through to the very edges of the system. There is a big downside, which is that your production code does change, but I personally think that is worth it. I have a ton of free resources online. I particularly recommend the Testing Without Mocks pattern language article. It is admittedly 40 pages long, but it is extremely detailed, and it goes to everything I've shown you here and a little bit more, including how to use this with legacy code, because this technique works with your legacy code without you having to change the design of your code. And that's huge. There's also a complete self-guided training course that I used to charge hundreds of dollars for. But I don't have time to do that anymore, so now I've given it away for free, and you can find it online there. And there's example repositories, including the one I've shown you here, live coding screencasts, much more. The examples I've given to you is the very, very beginning of the self-guided training, so check that out. It's very good, I think. So to wrap up, Nullables are an approach to testing that simplifies your code. They give you fast, reliable tests without the brittleness and complexity of mocks. They come with a fairly significant trade-off, adding support to your production code, but I think it's worth it. I've got those resources online at jamesshore.com/s/nullables, same thing as the QR code. Happy to answer more questions. I'll be right out there at the table. Thank you for coming.